Hello, my name is Velan Alakithirumaran with metric number 177163, and this is my presentation for my FYP proposal on the theoretical study of the dehydrogenation of cyclohexanol to cyclohexanone using reaction ensemble molecular simulation. In short form, it's REMC. Okay, so first, since the reaction is about dehydrogenation, let me give a short brief about the reaction. Dehydrogenation is the process removal of hydrogen from a OH bond of an organic molecule to form a double bond molecule. So it is a heterogeneous gas phase dehydrogenation at atmospheric pressure, and it's also a very highly endothermic reaction. Okay, about the dehydrogenation of cyclohexanol to cyclohexanone, it is majorly applied in caprolactam producing industry. Okay, why in caprolactam producing industry is because cyclohexanone is the raw material for the caprolactam manufacture. Okay, before we look at the general dehydrogenation of cyclohexanol reaction, this reaction have two different type of condition. One is the low temperature reaction and the high temperature reaction. Okay, like the image below you can see is the example of low temperature reaction where it uses copper catalyst, whereas high temperature uses zinc calcium oxide catalyst. So this image below, as you can see, is the general dehydrogenation of cyclohexanol to cyclohexanone, whereby it is the removal of hydrogen. Okay, our reaction ensemble molecular simulation involves the study of the adsorption reaction. So adsorption is a reaction that occurs on the surface of a molecule. It is the accumulation of liquid or gas on a surface of liquid or solid molecule. Adsorption can also be defined as the accumulation of concentration on a surface. Another way of defining adsorption is the strength of interaction between the adsorbent and adsorbed molecules. What are adsorbents? Adsorbents are the mass separating agent in adsorption. So few characteristics of a good adsorbent is that adsorbent should have a high internal volume. Why a high internal volume is so that it can be accessible for components to be adsorbed. Another important characteristics of adsorbent is that it should have very good kinetic properties. This is because to make the adsorbent capable of moving adsorbed molecules rapidly to the adsorbent site. Another few notable characteristics that adsorbent should have is a very good strength so that it doesn't rupture easily, and also a very good attrition resistance. Adsorbates, meanwhile, are the gas or liquid which are adsorbed on the surface of solid or liquids. So below the image shows a general adsorption process on how reacting molecules are adsorbed on the adsorbent. Okay, the main part is that about molecular simulation. So molecular simulation is basically the collection of methods of doing experiments via computer on molecule models. The molecule is modeled by the postulation of how it interacts to each other. So generally, the force of how molecules interact with each other is approximated by using simple and rapid computer function. This is what we call the modeled molecules for simulation. The value of thermodynamic properties follow the molecule interactions, and equations to evaluate them for molecular models are actually known when we create the model molecules. So what molecular simulation can give is that molecular simulation can help provide the family properties of a molecule such as viscosity, boiling point, freezing point, etc. etc. So why molecular simulation is important is because computer becomes a part of a numerical solution where it performs experiments on the model molecules which we created earlier and provides a result which we can estimate by comparing with readily available results, and so that the error can be reduced. Okay, the problem statement of this study is that first, the study of dehydrogenation of cyclohexanol to cyclohexanone in terms of molecular simulation has not been done. In previous researches, cyclohexanol to cyclohexanone reaction has been done in terms of catalyst or Le Chatelier principle based wise, but no reaction in terms of molecular simulation has been done. So the study here is to understand the fundamentals of adsorption in the dehydrogenation of cyclohexanol to cyclohexanone, and this research is also to test the usage of reaction ensemble molecule Monte Carlo simulation and PSRK applicability in the study of vapor phase equilibrium of this reaction. So in total, we are actually testing the usage of reaction ensemble Monte Carlo on the dehydrogenation of cyclohexanol to cyclohexanone and compare the validity with PSRK, which is the predictive Sauer-Lincoln equation. Okay, the research objective. The primary aim for this research is to utilize the reaction ensemble molecular simulation method to study the vapor phase chemical equilibrium for the dehydrogenation of cyclohexanol to cyclohexanol. Some of the specific objectives can be to model the cyclohexanol, and hydrogen, to study the effects of changes in temperature and pressure on the chemical equilibrium of the non-ideal vapor phase dehydrogenation of cyclohexanol to cyclohexanol, and finally to validate the result with predictive Sauer-Lincoln equation of state. Okay, some of the limitation of the study is that the result of simulation will be compared to existing PSRK equation of state. So since this research, as I said earlier, is the initiation of the applicability of reaction ensemble Monte Carlo simulation on this reaction, first we start with a simplified model first and validate it with PSRK, and based on the result, if we have time, we might go through a real model. But first we start with a simplified model, as this is the very first time we are doing this molecular simulation method on this reaction. So some of the literature review which I studied is first from Javier Carrero Mantilla and Mario Lano Restrepo. So their paper states that reaction ensemble molecular simulation is used for the hydrogenation of benzene to cyclohexane. So their result in their conclusion shows that the simulation shows an excellent agreement when validated with the Sauer-Lincoln equation of state. Another study from Lisal et al. States that the use of reaction ensemble molecular Monte Carlo method to study the reaction and vapor liquid equilibrium of the bromine chlorine and bromine chlorine system. So same like earlier paper, when they simulated the data and compared it with the experimental data which they chose, it showed quite a good agreement too. Whereas this journal instead from Ernesto et al. Is the paper that shows that research is done on the reaction of conversion of cyclohexanol to cyclohexanone based on the effect of catalyst. They chose the copper catalyst and changes the effect and check on how it affects the conversion. To the methodology. Now the methodology actually begins where we will develop the model for cyclohexanol, and hydrogen. Later, we will be developing the reaction ensemble Monte Carlo program using the Intel Visual Fortran compiler 2010 via coding. Then we will be revising the effect of temperature and pressure change on the vapor phase equilibrium of the dehydrogenation reaction, which is based on our research objective. And finally, we will compare the obtained final results with the predictive Sauer-Lincoln equation of state and classical thermodynamic model to determine the validity of the potential model we developed earlier in our methodology. So in our methodology, we will be using the predictive Sauer-Lincoln equation of state to validate our simulation result. So PSRK in short is the combination of SRK equation of state with the original existing unifact group method. So PSRK, why PSRK is widely used is because it does not require any binary interaction parameter for mixing rules that is used to compute the mixture parameters. So PSRK is generally used for the prediction of gas solubility and vapor liquid equilibrium at low and high pressure. With the combination of PSRK and UNIFAC, the UNIFAC database has been extended to the gases where it gases of supercritical condition by fitting gas solubility and vapor liquid equilibrium at very high pressure too. So PSRK method also is able to estimate the partial fugacity coefficient in the ternary system of cyclohexanone and hydrogen through the combination of UNIFAC. So next we'll be talking about the reaction ensemble Monte Carlo method. So this reaction ensemble Monte Carlo method is used as it has three kinds of trial moves performed in the box during simulation. So reaction ensemble Monte Carlo generally is a simulation where it uses a single simulation box to simulate single phase reversible reactions. So the three moves during simulation to achieve equilibrium are the molecular translational displacement, box volume changes, and reaction steps. So about molecule translation displacement, it involves rotational and rotational of the molecules and the displacement of the molecule. For rotational moves, random orientational displacements were applied based on choosing random values for Euler-Engels on rotation matrix. So it's more deeper and where it is defined by the Euler-Engel of the rotation matrix. The Euler-Engel is determined by the own simulation. Okay, for the reaction step, first a direction of the reaction is randomly chosen, either forward or backward. So if forward, the extent of reaction is equals to 1, and when the backward reaction is chosen, the extent of reaction is -1. For the forward reaction step, how it actually works is that a cyclohexanol molecule is randomly picked up and a potential interaction with other molecules is calculated before the cyclohexanol molecule is destroyed. Following this, a cyclohexanone molecule and also a hydrogen molecule is created in the same position that the cyclohexanol molecule is destroyed, and the potential interaction of the newly put molecule with the surviving molecules are calculated. This is how the reaction step is determined through the simulation. So it is vice versa if we choose the backward reaction. Okay, now for the interaction potential of the molecule model, we chose to use the Lennard-Jones interaction potential. So the Lennard-Jones equation is as below, whereby psi is equals to 4 epsilon sigma over R12 minus sigma over R power 6. So that is why we call it the Lennard-Jones 12-6 equation. The Lennard-Jones is actually an interaction mathematical model between molecules that will be used later in our study. So our molecules which will be modeled will be based on the Lennard-Jones, but since we are in the beginning part of our study, we will be soon later in the study will be determining the mathematical model for cyclohexanone and hydrogen later in the study. Okay, finally, the expected outcome of this study is that since REMC is being check the applicability for this reaction, so the outcome of this simulation is that we expect REMC to be applicable to determine the vapor phase equilibrium of cyclohexanol to cyclohexanone, and the result of simulation we expect to be in agreement with the predictive PSRK equation of state. So this is my Gantt chart which I created for the both semester of my final year project, and these are the references. This is not all the references, these are the few references which I took for now in this one. Further references will be available in my study journal later, I mean in my study report later. Thank you very much for letting me share on my topic regarding my FYP.